Hello, students. Mr. Kaczynski with you. We're going to do 8.4, practice your skills solutions. Here we go. First thing we're looking to do is use the zero product property to solve this equation. Remember, the zero product property states that if A times B equals 0, then A equals 0 or B equals 0. Not sure why I made that 0 so tiny. I don't like it though. I want to fix it. Here we go. All right, so that's the zero product property. Well, if x plus 4 times x plus 3.5 equals 0, then x plus 4 must equal 0. Or perhaps maybe x plus 3.5 would equal 0. Okay, I mean, so the solutions here are pretty obvious here. Is that if x is -4, or if x is -3.5, decimal point, there we go, that's this entire equation would be 0, because -4 plus 4 is 0. 0 times anything is 0. -3.5 plus 3.5 is 0. 0 times anything is 0. All right, over here, what are our solutions? X could be 2, because 2 minus 2 would be 0, or x could be 6, because 6 minus 6 is 0. The other thing we can do is we can graph these. 2 parentheses x minus 2, x minus 6. And we can look for where they cross the x-axis. There it is, trace at 2 and 6. There you go, 2 and 6 is what makes them equal 0, the y equals 0 right there. All right, what about this one? Well, there's 3 things. X could be -3, x could be +7, or x could be -8, any of those 3 things. I think we should graph this one. I was messing around with this one earlier too. So x plus 3 times x minus 7 times x plus 8. Graph it. You can see the 1, 2, 3 intercepts. If you change the window to like -300 and +300, you get a lot better look at what this thing looks like. That's what's happened. So we got like a double parabola here. This is a cubic function. So trace -3, there's one of them. 7, there's another. -8. I feel like I should have ordered these from least to greatest. That would have made more sense, right? All right, what about this last one here? X, it could be 0 or 9. Oh, not -9, but 9 or -3. There's my 3 answers there. So 0 times anything would be 0. 9 minus 0 would be 0 times this, still be 0. And -3 plus 3 is the last way we can get 0. Let's graph that one too. X parentheses x minus 9 parentheses x plus 3. Graph it. All right, let's go trace. 0, boom, that gives me an output of 0. 9, boom, that gives me an output of 0. -3, boom, that gives me an output of 0. We got it. All right, graph each equation and then rewrite it in factored form. X squared, let's clear this, x squared minus 4x plus 3, graph it. So the x-intercepts, you know what, I should probably change my scaling here. Let's go zoom 6. There we go. It's like 1 maybe. Let's trace it. Go 1. Yep, 1 is one of my x-intercepts. And my other one looks like it's 3. Yep, 3. All right, so in factored form, this is going to be y equals x minus 1 times x minus 3. That's called factored form. So we find the x-intercepts, and the opposite of those x-intercepts is kind of how they show up in our factored form. Let's put that in y2 and see if that makes sense. X minus 1 times x minus 3. Graph it. Nothing new is showing up because it's the same parabola, right? See in the table, so outputs are the same. All right, next one, let's graph this and figure out what the x-intercepts are. X squared plus 5x minus 24. Graph it. Our x-intercepts are -8. Yep, and what else? Looks like 3 again. Got it. So now I can write my factored form of my equation. Y equals x plus 8 and x minus 3. X plus 8 times x minus 3. I shouldn't say and, it's really x plus 8 times x minus 3. For sake of time, I'm not going to graph it, but you definitely should. 12x plus 27. Let's go to the graph. You know, and the table will show us the x-intercepts too, right? Let's go to the table. There's one of them, -3. X-intercepts, -3, and there's the other one, -9, right? See those on the graph too. Bottom line, our equation is y equals x plus 3 times x plus 9 when we write it in factored form. One more of these. X squared minus 7x minus 30. Let's go to the table. No, let's go to the graph. It's like -3 and 10. Oh, the x-intercepts are -3 and 10. Our equation is going to be y equals x plus 3, x minus 10. I am going to graph this one because I didn't really check the x-intercepts that closely. Like I didn't trace to make sure I was right. Let's just type this in, x minus 10. Let's go to the tables. They are the same. Just a duplicate. All right, there we go. Next up, number 3. Name the x-intercepts of the parabola described by each quadratic equation. Then you check your answers with a graph. All right. Well, they are 7, 0, and -2, 0. Or 7, -2, right? X minus 7 times x plus 2. Clear it. Here we go. -2, 0. Trace. -2, 0 is one of them, and 7, 0 is the other one, right? All right, so what about here? -1, 0, and -8, 0. -1 and -8. I'm writing them as points. It can be written either way. Definitely don't go 0, -1, and 0, -8. Those would be y-intercepts. Let's check it. 2 parentheses, x plus 1, and x plus 8. That 2 is just a vertical stretch. There's our -8, there's our -1. None of these had any vertical stretch in number 2. All right, what do we got here? We got 11. Ooh, boy, that's a tight 11. You know, so another way we could write this is like I was writing it on the last problem. The x-intercepts are 11 and -7. And over here, ooh, the x-intercepts are what? I know about the 9. That's pretty obvious. Okay. But then there are shortcuts to this. But maybe I'll just do this the long way here. 0.4x plus 2. What would make that 0? Well, if I subtract 2 from both sides of this equation, I get that. And if I divide both sides by 0.4, -2 divided by 0.4 is -5. So the other intercept is -5. Let's check and make sure that's the case. Clear that one off. parentheses 0.4x plus 2 and x minus 9. 0.4 of -5 would be like -2, yeah, and -2 plus 2 would be 0. There we go. So we got our trace. -5 is one of our intercepts, 9 is the other. Write an equation in a quadratic function that corresponds to each x-intercepts. Each of the x-intercepts, assume there's no vertical stretch or shrink. Well, I'm going to put this in intercept form, right? Let's go x minus 2.5 times x plus 1. Done. Let's do, how about this? X plus 4 times x plus 4 is x plus 4 squared. Let's look at that one. We haven't looked at this yet. X plus 4 squared. Graph it. See, it's just got that one x-intercept at -4, which happens to be the vertex as well. Let's do y equals x plus 2 times x minus 2. And lastly, how about y equals x minus the first root times x minus the second root, right? Right. Last one. Consider this equation. How many x-intercepts does it have? Well, it's got 2. They happen to be -1 and +3, right? So the vertex of this parabola we could find by doing -1 plus 3 over 2, which is 2 over 2, which is 1, right? That's the x value of our vertex. Okay, and then we could throw 1 into the equation, and we could do like 1 plus 1 times 1 minus 3. All right, I'm just taking this equation and putting 1 into both equations, like x plus 1 and x minus 3. So what's that give us? That gives us 2 times -2, which is -4. There we go. That's the vertex. Let's check. Y equals, clear it. X plus 1 times x minus 3. Graph it. Trace it. 1 and -4. There you go. That's our vertex. So we found the intercepts at -1 and +3. Halfway between those, 1. That's the x value of the vertex. Put the x value of the vertex into the equation. That gives us the y value of the vertex. Write the equation in vertex form. Okay, that's going to be y equals x minus 1 squared minus 4. Okay, so let's put that in there. X minus 1 squared minus 4. Let's go to the table. They are the same. Great. The graphs, same parabola. Write a description of this. I would say the parent function y equals x squared has been translated 1 unit right and 4 units down. A couple different color there. Let's go a lot bigger. There we go. Gotta fix this too. I don't remember how. Doesn't matter. Let's put this little symbol here. There you go. X to the power of 2. We're done? We're done. Thanks for watching. You're awesome.